we'll go to the next topic, that is telescope. Telescope is an optical instrument and it is used to view the images of distant objects very distinctly. And there are, depending upon its usage, that is if it is used to view the objects in the earth, it is called as a terrestrial telescope, and if it is used to view the objects in the space, it is called astronomical telescope. This astronomical telescope is that what we are going to study now. It consists of two lenses. One is called as the objective lens of very large focal length and aperture, and an eyepiece of very short focal length and aperture. These two lenses are fixed coaxially at the two ends of two tubes, and the distance between the two tubes can be adjusted using a rack and pinion arrangement. Now we are going to see about the magnifying power of the astronomical telescope. First, when the final image is formed at infinity. As you know, when the image is formed at infinity, though the magnifying power is less, we'll be able to see the image with a relaxed eye. Now, as you see in this figure, this is the objective lens of large focal length and aperture. Now, the object is at an infinite distance, for example, stars, planets, etc. So, light from them, they are passing through this, or they get refracted as they pass through this convex lens. Since the object is at infinity, the image should be formed at the focus of this lens. So can you see this? This is the A dash, B dash, supposed to be a diminished image which is formed at the focal length of this objective lens. So when the object is at infinity, image is formed at the focus of this lens. So I have named it as, it is formed at the focus of this lens. So this position is FO for this objective lens. Now we know that this image that is formed acts as the object for the eye lens. The eye lens is of short focal length and aperture. If the final image is to be formed at infinity, this position of this object has to be adjusted such that it lies at the focus of the eye lens. So you adjust it and place it, that's why I have marked it as FE. So actually FO is the focus of this objective lens where the image is formed. Now you have to adjust the position such that it lies at the focus of the eye lens. So in this figure you can see that a ray of light parallel to the principal axis after refraction passes through the other focus. Another ray of light passing through the optic center goes without any deviation. When these two rays are extended, they appear to come from infinity. Here again I have considered two refracting rays. So they get refracted and they move parallel towards our eyes. When extended, they appear to come from infinity. So here we are getting the final image at infinity, and now let us calculate the magnifying power. Magnifying power can be defined as the ratio of the angle subtended by the final image at the eye when the image is formed at infinity to the angle subtended by the object at the eye when the object is also at infinity. So the angle subtended by the image at the eye when the image is at infinity to the angle subtended by the object at the eye when the object is at infinity. Now beta is the angle subtended. This is a line coming from infinity. So beta is the angle subtended by the final image at the eye. Alpha is the angle subtended by the object at the eye. But the distance between these two lenses are very small compared to the distance of the object from the telescope. So it doesn't matter if the angle is subtended either at the objective lens or the eye lens. The distance between them is very small compared to number of light years. which is the distance between the object and the telescope. So I have marked this angle to be alpha. So this vertically opposite angles, this is also alpha. Now to calculate the magnifying power, since beta is small, tan beta is beta, tan alpha is alpha. From the figure, let us see what is tan beta. What is tan beta? A dash B dash by C2 B dash. What is tan alpha? A dash B dash by C1 B dash. That's what I've written over here. So what is magnifying power? Magnifying power will be A dash B dash by C2 B dash into C1 B dash by A dash B dash. So A dash B dash will get cancelled and we get N to be equal to C1 B dash by C2 B dash. Now tell me what is C1 B dash. C1 B dash. It is the image distance of the objective lens. Where is the image formed? At the focus. Where is it? To the right of the lens. So we can mark it as FO. O means objective lens. Focal length of the objective lens. It is positive since it is to the right. What is C2B dash? C2B dash is, where do you place the object? It is placed at the focus. So what is this distance C2B dash? It is the focal length of the eye lens. And since it is to the left, we mark it as minus FE. So this is the magnifying power of the astronomical telescope when the final image is formed at infinity. From this expression you can see that the magnifying power can be increased by decreasing the focal length of the eye lens and increasing the focal length of the objective lens. Also, the distance between the two lenses, this is FO and this is FE. So the length of the tube can also be written as FO plus FE. This is about the astronomical telescope when the final image is formed at infinity.